Hello everyone, this is for Algebra 2, Section 1.3. The biggest thing that you guys need to get out of this section is PEMDAS. It's order of operations, parentheses, exponents, multiply, divide, add, subtract. And there's two differences. Notice in this one, you're just evaluating this. You're just going to figure out what is this thing worth. When you're doing that, you start at the top of PEMDAS and work down it. So this is when you're going to evaluate something. Evaluating is going down. This one is you're going to solve the equation. You're going to figure out what is x worth. When you do that, the order that you're going to get rid of stuff is going up PEMDAS. So they're reverse orders in what order you do things or get rid of things. All right. So if you were going to do this one manually, the first thing you have to do is take care of what's inside the parentheses. -2 plus 7, so it would be -9 cubed. Then you'd go after the exponent, and you'd take care of this exponent before you would multiply by 7. So that's going to be a giant number. Let me type it in the calculator. So -9 cubed is going to be -729. So you'd have -2 plus 7 times -729. Exponents are done. Then you're going to go after multiply, and you'd multiply these two things together before you'd add a -2. So times 7 gives you -2 plus -5103, 5,103. Now, the multiplying is done. Multiplying and dividing get done at the same time, whichever one you come to as you read from left to right first. So actually, you got both of these taken care of. Then you'd go on to do either adding or subtracting. And so your final answer would be -5105. Okay? So that's the order you do things. Now, with that said, by all means, type the sucker in your calculator as you see it from start to finish. Parentheses, everything's the same. We talked about last section how to get an exponent in there. Okay? So you got that taken care of. I'm not looking for you guys to do this manually. I'm just explaining this is a frame of reference that you have. You've done this in the past. When you're doing this, you're going down PEMDAS in that order. When you're solving an equation, however, you're working on stuff going up PEMDAS. So you're going to undo any adding and subtracting first. I understand this is an adding, but it's in the parentheses. I can't touch it until I'm up here at the top with the parenthesis. So the first thing you have to do is get rid of this 5. It's like a teeter-totter, and it's balanced. If you are going to add 5 to this side of the teeter-totter, you have to balance it to add 5 to the other. So I'm going to add 5 to this side and add 5 to this side. So I got 3, the parenthesis x plus 2 squared is still there, equals 15. There's no more adding and subtracting outside the parenthesis to get rid of. So you're going to go after getting rid of any multiplying or dividing. Here you're multiplying by 3. You cannot multiply that inside. You have to make it go away. So you divide by 3. So you have the quantity x plus 2 squared is equal to 5. Now, these two things are taken care of. These two things are taken care of. I'm at the exponent stage. I have to get rid of this exponent. I think you guys have learned by now what undoes a square is a square root. And we're going to talk a lot about this year. Whenever you have a variable and you put an even root on the page, even root, what do I mean? How about I just leave it as it's a square root? When you put a square root on the page that wasn't there before, a plus and a minus is going to show up. So I have x plus 2. I'll talk more about that in just a second. Let me finish this one. Now, the parentheses are gone. The exponent was gone. The parentheses gone. You return back to the bottom and take care of anything that was in the parenthesis. I have to get rid of the equal sign is there. Subtract the 2. So I have x equals -2 plus or minus the square root of 5. You guys are welcome to leave your answer looking like this, but just explaining. You have -2 plus the square root of 5, and you have -2 minus the square root of 5. That's what this plus and minus means. You're adding the square root of 5, you're also subtracting the square root of 5. You have two separate answers. You're welcome to leave it right there. If you want, you can write both of these. Okay? Now, returning back to this plus and minus thing. If I give you the square root of 16, that's what's written on the page. That answer is 4. It is not plus and minus 4. if I give you x squared is equal to 16, and you square root both sides, then that's x equals plus or minus 16. How about you think about it this way? If you type that in your calculator, it will only tell you 4. Try it. Type it in. Your calculator is a pretty smart tool. If it was meant to be a plus and minus 4, don't you think it would tell you? Yeah, it would. Okay? Now, another way to think of it, isn't this one number? It's only one number. How could it possibly be worth more than one thing? It can't. Whereas this one, that's a variable. Isn't a variable supposed to vary? Isn't there more than one option it could be? That's the whole idea of a variable. When you square root this thing, the plus and the minus really is coming from the variable. It's not coming from the number. This side is really just 4. Whereas this side, I'm not trying to confuse the pants off you here, but here you go. The plus and minus really belongs on the x. But you get rid of it by taking them to the other side, and that's how you get plus and minus 4. The plus and minus comes from the variable, not from the number. We'll spend a lot of time talking about this year. Okay, a lot of kids sometimes have a hard time getting their head around this, so it definitely is something we're going to concentrate on. But I want you to walk away with, if I give you this, it's just one number. If you end up putting a square root on the page that wasn't there before in the process of solving, that's when the plus and minus is going to show up. When you put the root on the page, it didn't already exist, and you got a variable with it, that's when it's going to show up. Okay? All right. So, back to PEMDAS. You're solving equations, so you're going up it. This is a pretty simple one. All you're going to do is subtract 5 from both sides, and you got x is equal to, what would that be, 6? This one, add 5 to both sides. X is equal to 26. Not so bad. All we did was, we're right down here at the bottom. Here, there's no adding and subtracting to get rid of, so I'm just going to get rid of this 3. It's held by multiplication, so I'm going to divide it out. X is equal to 8. Here, I'm dividing by 3 right now. What undoes division? Multiplication. So I'm going to multiply by 3. Let's see, if that was 20, I'd get 60, so 72, I think. All right, you can try that, 60, 72, I think so. Now, when you guys are multiplying by fractions, sure, you could go divide 2/3. This is pretty bad etiquette. It's kind of like the equivalent of chewing with your mouth open at the dinner table. Nobody likes it, and you're not supposed to do it. Same deal here. Don't divide when you have a fraction. Okay, it leads to what's called a compound fraction, a fraction within a fraction. And that's, yeah, generally not very palatable. When you have a fraction, to get rid of it, multiply by its reciprocal rather than dividing it. Multiply by its reciprocal. And you guys should know, multiplying any reciprocals is going to give you 1. 1x equals, a little fancy reducing here, 2 goes into 24 12 times. 12 times 3 is 36. So your answer is 36. Do you need the 1? No, you don't. I just did that to illustrate the point that when you multiply reciprocals here, 6 over 6 is worth 1. Okay? Multiply by the reciprocal. And if you guys really don't want to type in 20 or do 24 times 3 halves in your head like I did by reducing it, you can type this in your calculator just as you see it. 24 times 3 divided by 2, and it will give you 36. I'd love it, however, if you guys could reduce that. That would be fantastic. That would so make my day. Okay, 2 goes into 24 12 times. I'm reducing, I'm canceling. I'm not cross multiplying. Somewhere along the line, kids get in their heads, you cross multiply when you have fractions. No, you don't. That's when you have a proportion, and that's something different. I won't bring that up today. All right. All right. Here, it's still a little more complicated. We're going to start putting multiple ideas together. You're still going up PEMDAS, and these are the kind of the levels that you work with. Undo any adding and subtracting first. So I'm going to add the 6. I got 3x is equal to 30. I'm at the multiply and divide stage, so now I'm going to divide by 3, and you get x is equal to 10. So there's the first one. I'm going to start by subtracting 5, and you get x over 3 is equal to 19. You're dividing by 3, so to make it go away, multiply by 3. So x is equal to 57. I think that's what that's worth. Subtract the 4. 2/3 x is equal to 20. Get rid of multiplying by 2/3 by multiplying by 3/2. Multiply by its reciprocal. Again, I'd love it if you guys could reduce diagonally, cancel diagonally. That's 10. So x is equal to 30. 3 times 10 is 30. When you have a parenthesis with it, don't sweat it. It's not going to, make it awfully difficult. It's still in the process. Undo adding and subtracting first. I can't touch this until I get up to the parenthesis level. So I'm going to add the 36 first. Oops, plus 36. So 3 times x minus 6 is equal to, so that would be what, 60? You could distribute this in, but you want it to go away. So why not just make it go away? So you have x minus 6 is equal to 20, and add the 6. So x is equal to 26. Here you're going to subtract the 5, sorry, I hesitated there. X plus 1 over 3 is equal to 19. You're dividing by 3. I can't touch this adding the 1 until I get rid of this 3. So you're dividing by 3, so multiply by 3. X plus 1, whoops, sorry about that mistake. X plus 1 is equal to, I think that was 57. Subtract the 1, x is equal to 56. Now, in your guys' homework, I'm asking you to show your work. This is what I'm saying by showing your work, and I think you guys understand what it means to show your work. If you guys just write down the answers, I'm not going to accept your homework. You have to show me how you're doing this. Have to show me your work. Learning to show your work, getting the math out of your head and letting it happen on the paper is one of the big roadblocks that kids start to bump into in Algebra 2. Is that they're so used to just doing the work in their head that they really start to fail. And I mean fail because they're not willing to let the math happen on the paper. You will quickly come into problems where you can't do the math in your head. Trust me, have faith in what I'm telling you is true. Been doing this for quite a few years, and I really feel that when kids start to struggle in Algebra 2, it's because they're resistant, unwilling, stubbornness to let the paper do the work for you. So I'm telling you, get used to showing your work. It will make the math later that's so much harder, so much easier. You could distribute this in. All I'm suggesting is make it go away. Multiply by its reciprocal, and then it's gone. You don't have to deal with it anymore. This will be out of there, and you'll just be left with x plus 4 equals, this reduces again, 12. 12 times 3 is 36. Subtract the 4, and x is equal to 32, and you're finished. All right, I think that's the last one for the page. When you have variables on both sides, you have an option. I'm going to rewrite this. 3x minus 2 is equal to 5x plus 4. I could start by subtracting the 3x. And I get, whoops, this is gone. 2 is equal to 2x plus 4. Or I could start by subtracting the 5x. And I'd have negative 2x minus 2 is, oops, yeah, that's right, equals 4. I thought I made a mistake. I know they look different, but it's going to give you the same answer. Now I have to subtract the 4. So I've got, sorry guys, I'm going to just ignore this one for a second. 2 minus 4 is negative 2 is equal to 2x. Divide by 2, and you get negative 1 is x. Showing you here, whoops, these aren't going to come out to be the same. Oh, it's because I lost the sign right there. That's a minus 2. Pardon my arithmetic. You would think I could figure out what I was writing. Sorry about that. Negative 2 minus 4 is negative 6, so that's negative 3. I'm going to add the 2 over. I have negative 2x is equal to 6. divide by -2, and you have x is equal to -3. So all I'm saying is there are options on where you can start. You don't have to do them both ways. I'm just showing you options. Okay? This one, you're going to have to distribute inside first. Dividing this out isn't going to help because it doesn't, and then you got fractions to deal with, gross. Okay? So start by distributing this inside, and it goes to both things. 3x minus 6 is equal to 5x plus 4. I'm going to start by moving the 3x over. So I have -6 is equal to 2x plus 4. Subtract the 4. So then I have -10 is equal to 2x. Divide by 2. And -5 is equal to x. Okay? Same thing's going to happen here. Start by distributing this inside. 3x minus 6 plus 7 is equal to 5x plus 4. You can bring those together. They're like terms. How about cut the 3x off? I guess I'm partial to doing that. I've done that in every single one of them. So 2x plus 4. Subtract the 4. I don't know why I closed it there. So I have -3 is equal to 2x. Divide by 2. And you have -3 halves is equal to x. Same thing's going to be true here. Distribute it in. 3x minus 6 plus 7x is equal to 5x plus 4. You have x's, these are like terms, so I have 10x minus 6 is equal to 5x plus 4. How about I switch things up and move stuff this way? So I have 5x minus 6 is equal to 4. Add the 6. 5x is equal to 10. Divide by 5, x is equal to 2. Okay? I know I was going kind of fast, but I'm not trying to make these videos half-hour long. If you need to, rewind it and play that section back. Okay, solving with fractions. Show you guys a couple little tips on how to do that. If you guys, I don't know, in middle school you kind of got it beat in your head that you can't have improper fractions. No, there's nothing wrong with improper fractions. You don't have to write that as 3.5. The only reason I'm going to do that here is to make it a little bit easier to work with. You can write it as 3.5 or 3.5, it doesn't matter. I'm just doing that to avoid typing this thing in my calculator. I'm going to subtract the 2x from it. Now, hopefully you guys can do this in your head. 3.5x minus 2x is 1.5x. Add the 1. So you have 1.5x is equal to, what is that, 6? And then you guys can divide by 1.5. Now the only issue here is you can't leave it here, you got to type it in. So let's see. Here, I'll just do it. I was going to do it in my head, but you know what? Why? Okay, 4. So you get 4. Answer's 4. An option trying to reinforce this idea, 1.5 is 3 halves. If you guys left this stuff as fractions, you could multiply by the reciprocal. This reduces. 2 times 2 is 4. I know kids hate fractions. I'm just trying to encourage you to try it a little bit differently. If you guys want, you can type this in your calculator. Subtract the 2x, subtract the 2x. You can type in your calculator 7 divided by 2 minus 2, and it will give you 1.5. Okay, the x is, I just introduced the x because there was an x there. The calculator can handle this. It can handle it as, right here, I guess I'll erase this step right there. Whoops, I want the eraser. Erase this thing right here. If you guys left it as 7 halves, not a problem. The calculator will do that. Type in 7 divided by 2 minus 2, and it will show you 1.5. Okay? I'm not trying to show you anything differently or demand that you guys do it this one way. I'm just giving you options on how to do this. All right? Now, one thing to notice, this had an equal sign. They're going to switch back. This thing's an equation. This thing's an expression because it doesn't have an equal sign. So how you work with it is, this is going to distribute inside x squared minus 5x plus 3x squared plus 21x. They said simplify by collecting like terms. Okay, things that have the same variable with the same exponent are like terms. That's 1x squared plus 3x squared is 4x squared. Minus 5x plus 21x is 16x. This would be your answer. You're not solving anything. You're just collecting like terms. And that appears to be the last screen, so thank you very much for your time.